Hey everyone, and welcome back to my channel. Today we have a popular LeetCode problem, minimum size subarray sum. This is a medium level problem and it's perfect for learning how to solve array problems efficiently using the sliding window technique. Before we dive into this problem, please make sure to check out my previous video for a deeper explanation for the sliding window technique. Alright, let's dive into it. Okay, we are given an array of positive integers and a positive integer target. Our goal is to find the minimal length of a contiguous subarray whose sum is greater than or equal target. If no such subarray exists, we return 0. Let's show this example. Okay, we have target 7. We have nums 2, 3, 1, 2, 4, 3. And the output is 2. The subarray 4, 3 has the minimal length of 2 and satisfies the condition because its sum is 4 plus 3 equal to 7. Please notice that the subarray must be contiguous and we need to minimize its length. Okay, the other example, the target 4 and nums 1, 4, 4. Okay, the output is 1 because the minimum size is 1. We have 4 and we have also this 4. And the third example, the target is 1, 1. Nums all fill with ones. Okay, the output is 0 because there we cannot make a subarray that its sum equal to 11, so we return 0. Okay guys, let's take this example. We have target of 7 and we have this nums array. Okay, the sliding window is about let's create a pointer to chair to the first element at the window. Okay, let's name it left. Okay, and we have a sum variable and we have minimum length. Let's make it ml. Okay, our first window, let's take the first subarray, the first element. Okay, we have 2. The sum is 2. Okay, now 2 more or equal or less than 7, the target. 2 is too small than 7. So let's expand our window to take the next element. So now the sum is 5. 2 and 3 equal 5. Okay, 5 is still less than 7. So let's expand our window again. 2, 3, 1, we have 6. And 6 is still less than 7. So let's take the second one. Okay, now we have 8. 8 is more than 7. So we should shrink our window. But first, let's know what is the minimum length. Okay, when we reach a sum that more or equal to the target, we should find the minimum length. Okay, now we have length of 4. We have 4 elements. Okay, and let's shrink the window by deleting this one. So our window is 3, 1 and 2. And don't forget to, okay, let's get the blue one. Our L is here now. Now let's take okay, don't forget to subtract the first element from the sum. So now the sum is 8 minus 2, which is 6. 8 minus 2, which is 6. Okay, let me remove the minimum and rewrite it here. Okay, ml as we say, it is 4. Okay, now 6 is less than 7. So let's expand our array. Let's expand our window. Now our window have this. Okay, we have 6 plus 4, we have 10. Okay, and 10 is greater than 7. So we should find the new ML, which is the minimum between the minimum length and the new length. Okay, what is the minimum between the new length, which is 4, these four elements, and the 4, still 4. So, and don't forget to move the left there, and don't forget to shrink our window. Now our window start from 1, and don't forget to subtract the first element, the left element, from the sum. So now our sum is 10 minus 3, which is 7. Now let's ask, 7 equal greater or less than the target? Okay, 7 equals 7. So let's shrink our window again. Now the ML, the minimum length, is the minimum between 4. Okay, this is 4 and 3. This new window, the current window, we have 3. So what is the minimum? Equal 3. And don't forget to shrink the window by removing the first one. Okay, and don't forget to move the left. Now our window containing of these two elements, and don't forget to subtract the first the left element from the sum. Okay, 7 minus 1, we have 6. Okay, 6 is smaller than 7, so let's expand our window. Now we have, let's take the second element. Okay, 2, 4 and 3, we have 9. Okay, we have 9. The sum now is 9. 9 equal greater or less than the target 7. 9 is greater than 7. So let's shrink our window by deleting the first element and moving the left, and don't forget the minimum length still 3 of this element of this window. Okay, now, and subtract the first element we deleted from the sum. Okay, now 9 subtract of 2, we have 7. Okay, now 7 is equal to 7, so we should okay, we have the length of 2, so what is the minimum between 3 and 2? Our current window length. Okay, the minimum is 2, so the minimum length is 2. Okay, now 7 is equal to 7, so we shrink our window again and move this here. But now we finished our array. Okay, and the minimum length we have is 2, so we should return 2. So guys, let's go to write the code. We have sum, as we say, initially it is 0. We have the minimum length, min len. Okay, initially it should be the maximum or the most infinity larger number in the world. Let's initialize it by infinity. Okay, float of infinity. Okay. Okay, why we initialize the minimum length with infinity? Because when we compare the length of the subarray with the minimum length, we cannot initialize it with 0, because always we could get 0. So okay, what we want to okay, we have the left pointer initialize at the first element at index 0. Now we have a for loop. Okay, the right element, okay, range nums. Okay, now we should keep expanding our window by sum, or calculating the sum for the elements. So sum equal, we keep summing nums of the right element. Okay, now okay, if we find the sum greater or equal the target, we should do what we did now. Okay, while sum greater or equal target, okay, we what we say, okay, in the drawing on the whiteboard, we find the minimum length equal the minimum, as we see previously in the whiteboard, guys. Okay, the min length and right minus left plus 1. Okay, we updating the minimum length by shrinking the window. Okay, where's the one? Okay, guys, what we also have, okay, we must subtract the sum, the first element from the sum. So sum minus nums of the left element we shrinking or we deleted. Okay, and don't forget to move the, okay, we have equal here. Okay, don't forget to move the left pointer forward, left 1. Okay, after we finish, we should return the minimum length if the minimum length not equal infinity, not equal float. Okay, otherwise we should return 0, because if the minimum length is still infinity, we should return 0, so we do not reach our minimum substring length. So let's run our code. Okay, we have error. Okay, the right, run again. Okay, okay, here also we miswrite right. Okay, let's submit to make sure all the cases passed. Okay, oh great. Okay, guys, if you look at our code, we have time complexity of O of n, linear time complexity, because both pointers left and right traverse the array just once. Each element is processed at most twice, once when added to the sum and once when removed. Okay, and the space complexity is O of 1, because the only use of a few variables left and sum and min length. So, to summarize, we solved the problem using the sliding window technique, which is highly efficient for problems involving contiguous subarrays. If you found this tutorial helpful, please give the video thumbs up, subscribe to my channel for more problem solving tutorials, and let me know in the comments which problem you'd like to see next. Check the description below for a deeper explanation of the sliding window technique and links related to problems. Thank you for watching, and I'll see you in the next video.